Welcome back. Today, we're diving into a fundamental concept that underpins all of AI, inference. At its core, inference is simply the process of drawing a conclusion based on evidence and reasoning. It's how AI models go from knowing a lot of information to providing a thoughtful answer.
Simply put, inference is the process of a computer reaching a conclusion based on knowledge it already has. It is a critical step that makes AI intelligent. Traditionally, philosophers have divided inference into two main types: deduction, which is reasoning from a general rule to a specific conclusion, like concluding a specific object is heavy because all objects of that type are heavy. The second is induction, where you infer a general conclusion from specific observations, like seeing several white swans and concluding all swans are white. In the world of AI, researchers develop automated inference systems to emulate this process. It is this capability that allows AI models to take what they've been trained on and use that knowledge to respond thoughtfully and reason through a new problem.
A perfect example of inference using an expert system is a classic program called Mycin. In the 1970s, Mycin was designed to help doctors diagnose and treat bacterial blood infections. Its intelligence was not based on learning from data, but on a large set of if-then rules provided by human experts. Here's how inference worked in Mycin. The premises: the doctor would input a patient's symptoms and lab results. For example, the patient has a fever, and the stain of the organism is gram-negative. These are the premises, or the initial information. The inference engine. Mycin would then use its inference engine to apply its rules. It would check if any of its if conditions match the input data. The conclusion, when a match was found, e.g., if the stain is gram-negative, it would follow the then clause to a new conclusion, a likely diagnosis or a treatment recommendation. The final diagnosis and treatment plan were the inferred conclusions, derived directly from the initial patient data and the system's codified rules. This process is a clear demonstration of inference, using a set of known facts, the rules and patient data, to logically derive a new conclusion,